In this study, researchers aimed to investigate the impact of cured meat consumption on cancer risk in both rats and human volunteers. The link to the study is in the description. They tested the effects of various additives on biomarkers associated with cancer risk in rats and identified calcium and tocopherol, vitamin E, as potential agents that could counteract the negative effects of cured meat. They conducted a 14-day study in rats, where they added 6 different compounds to cured meat and measured fecal biomarkers. Based on these results, they selected calcium and tocopherol for further experiments. In a 100-day study, they fed rats a diet of cured meat with or without calcium or tocopherol, and found that these additives reduced the number of preneoplastic lesions in rat colons. Furthermore, they conducted a crossover study with human volunteers who consumed cured meat with or without calcium or tocopherol for 4 days. The results indicated that cured meat increased nitroso compounds and lipoperoxidation in human stools, both of which are associated with cancer risk. However, calcium normalized these biomarkers in both rats and human feces, while tocopherol decreased nitro compounds in rats and lipoperoxidation in human feces. Overall, the data suggest that adding calcium carbonate or tocopherol to cured meat may help reduce the colorectal cancer risk associated with its consumption. This study provides insights into potential strategies to mitigate the harmful effects of cured meat on cancer risk. This study found that consumption of cured meat, specifically dark-cooked meat treated with nitrite and oxidized by air, DCNO, led to an increase in biomarkers associated with the promotion of colon carcinogenesis in both rats and human volunteers. The research demonstrated that this increase could be mitigated by dietary calcium carbonate and tocopherol, vitamin E. In rats, the study showed that the number of precancerous mucin-depleted foci, MDF, was reduced by the addition of calcium carbonate and tocopherol to the diet containing DCNO. The study also found that the fecal biomarkers associated with cancer risk, including N-nitroso compounds and lipid peroxidation, were normalized in both rats and human volunteers when these additives were included in the diet. This research suggests that the inclusion of calcium or vitamin E in cured meat products may help reduce the colorectal cancer risk associated with their consumption. Furthermore, the findings provide insights into potential strategies for altering the curing process of meat to reduce its cancer-promoting properties. This approach could be beneficial in reducing the burden of colorectal cancer, especially among individuals who consume high amounts of processed meats.